Hey, actuaries, happy Friday. Do you wonder if AI will take your job? Well, it won't, but someone who uses AI will. That's why you need to use AI to make yourself a better actuary. I'm going to show you how Xval lets you use AI to build actuarial models. Xval is powered by a domain specific programming language called Exact. Domain specific just means that Exact was designed for a particular purpose, in this case, specifying actuarial logic. So Exact can't do everything, but it's really good at the thing that it was designed to do. Since Xval is powered by code and AI tools are really good at writing code, we can use AI to make our lives better. That's why we set up an AI workflow in Xval that you can use to write code in Exact. Let's see how it works. Okay, we're in a fresh environment at demo.xval.io, which, by the way, is a site that you can visit to try Xval for free. And I'm just going to submit a query to AI that I've already got planned here. We're going to ask it to write a script that projects SPIA benefits for 360 months. And we want to include an example extract with policy number and benefit amount. And we want to assume assume an annual mortality probability for 1% in all years. Okay, so let's submit this. We're going to have to wait a moment for it to finish.
75 years later.
Okay, so it looks like it did a good job with the mortality rate, and it has a monthly mortality rate that it computes, and then it creates a lives in force, and then it computes the benefit payments. And the error that it made is that these columns are not allowed to have a column name that's the same as a special function. So we just have to fix that really quick. So I'm going to hit accept here. And then we can click in to see this module that it generated. We see it didn't compile successfully because I need to delete these columns. And if I save, now it is working. Great. So let's see what happens when we run it. So now we are in a run that we've created, and we're looking at the module that we're about to run. So if I hit run again, now we've got the screen to actually kick off a run. Let me pick the extract that we just created. This is the extract we just created. Which I've now assigned to our extract table in our run. And now I'm just going to tell it that I want to keep some of the projections. So let's just keep the first 3 projections by setting this right here. And then I'm going to hit start run here. And so it will run this. And now it's done after 3 seconds. Let's check it out. Okay, here we can see our lives in force being projected. The monthly mortality is the same in every period, obviously, but our benefit payment is going down. It's being decremented by the lives in force. And so, yeah, we got our result just by generating a table and a module with AI that was able to run with minimal changes. Now let's do something a little bit trickier. We're going to go back into our AI panel here, and we're back on the module that we created. And I'm just going to, you can see that this module is in context here. And I'm just going to say, can you modify the mortality rate so that it is specified for each policy in the extract? Question mark. All right, let's see how it does with that one.
75 years later.
And what I'm hoping to see is that mortality rate will say policy.mortality rate now. So now we're pulling the mortality rate for each policy. And we need to, and it did not generate an example extract, which I hoped that it would kind of infer that that's what I wanted, but it did not. So let's say, can you also generate an example extract with the mortality rate included?
75 years later.
And we've got it. So I will hit accept here, and this will generate a new example extract here, which is called SPIA extract 1 because the SPIA extract name was already taken. So let's go back to our module. We've modified this module, and we are going to run it with our new extract. So I'm going to call it example 4. And then I'm going to assign the new extract that we just created, assign data, and I'm going to go back here and then hit start run. And we'll just have to wait a few seconds.
75 years later.
Okay, so now let's look at our most recent run, and we can check out The mortality rate for this one is 1%. The mortality rate for the second policy is 1.2%. Let's see if that matches the extract we just created. And it does. We see the 1%, 1.2%. So that's it. I've shown you how you can generate and modify actuarial models using Xval. If you want to try Xval, you can do that at demo.xval.io. You can also visit our website at xval.io, and you can reach out to me on LinkedIn or over email at timothy.quast@xval.io. Thanks. Bye.